In Python, everything is an object, be it integers, floats, strings, booleans, list, functions, classes, modules, and every other language construct is conceptually an object. Consider the following piece of code. The part at the right hand side of the assignment operator is actually creating object of an integer type and attaching the name height to the respective object. The object created comes with a bunch of built-in attributes and member functions. But how do we verify that the objects pointed to by the height variable is actually an object? So here the built-in function dir is being used. This function dir returns a list of attributes in an object. The attributes could be variables, functions, modules, and other things. If we call this method with height as argument, or even the value 2, that is an integer, as an argument, we get the following result. This output presents the list of attributes held by the object pointed to by height. The object pointed to by height is an instance of the integer class. The names mentioned in the above output could be referring to variables, functions, modules, and other things. In Python, variables are names mapped to objects. In the classical sense, variables can be visualized as containers of values. When a variable is declared as int, the compiler or runtime allocates a memory chunk just sufficient to hold an integer value, and hence we cannot put floats or other types in that container. But in Python, variables are more like labels attached to objects. This is why we do not need to define the type of a variable in Python. And this is why we can map any label, that is any variable, to any object type. Instead of variables, that is in the classic sense, Python has names and object bindings. This crucial difference has serious implications. Consider the following two scenarios. First, we will consider the following piece of code in C language. The first line allocates 4 bytes for A and stores 45 at that location. The second line allocates 4 bytes for B and copies the value of A, which is 45, at that location. It is to be noted that A and B are names pointing to two different memory locations, which is 1000 and 2000 over here. But both the memory locations are carrying the same value, that is 45. This can be verified by using the AND operator to get the addresses of A and B. So over here, it can be seen in the output that A and B are two different memory locations, but they are carrying the same value, which is 45. Now let's consider a similar piece of code in Python. In the first line, the Python interpreter creates an object of type int and binds it with the name A. The second line binds B also with the same object. After these two statements, we can say that both A and B are bound to the same object. This is how binding of objects takes place in Python. This can be verified by making use of the built-in function id. This function returns an integer representing the identity of the object. So over here, we can see that both labels A and B are pointing to the same objects, that is, the addresses or the memory references are same.